Session 4.3 Complements and Conditional Probability. Probability of at least one. At least once means one or more. When we're looking for the probability saying that at least once, it means we want to find the probability that is one or more. Complement of getting at least one particular event is that you get no occurrence of that event. For example, if I say find the probability to get at least one blue marble, the complement of this particular event will be probability that not to get any blue marble. Okay, remember we learned the complement events on the session 4.1. We apply like this formula. Probability of complement of A equal to 1 minus probability of A. So in these sessions, we will apply the same formula. When you guys see find the probability of at least once, then you need to know how to write down the complement of the event. Just like this example, getting at least one blue marble, complement will be not to get any blue marble. So probability of at least one, that will be probability of at least one equal to 1 minus none of it. Example 1. A fair coin is tossed 5 times. What is probability that it comes up head at least once? I want you guys highlight the at least once. When you see this is what we're looking for, you need to think about the complement formula. So first, let A equal to comes up heads at least once. Think about it. What is the complement of A? Remember we say if we want to find the at least once, the complement will be not to get any, right? Or you could think about none of it. So now I want to get the heads at least once. The complement will be come up tails all 5 times. Or you could think about it, the complement of A will be not to get any head. If we don't want to get any head, that means we want to get all tails. We do have a 5 times because we toss the coin like 5 times. So start with this formula. Now I'm gonna flip the coin like 5 times, and each time I want to get the tails. So think about it. The first tail, what is probability to get the tail? That will be 1/2, right? And then second time, when I flip the coin, I want to get the tail again. And remember, this is called the independent event because the second time when I flip the coin, it doesn't affect by the previous one. So I will have the same number, 1/2. The third time, I want to get the tail. Fourth time, same thing. Fifth time, it's gonna be same thing. Okay, one more time. So we are looking for the probability getting heads at least once. So we'll be using the complement formula. 1 minus probability of none of them will be head. None of them will be head, that means it gonna comes up tails all 5 times. So we will have 1 minus 1/2 to the power of 5th. Use your calculator. You're gonna get this answer. Example 2. When 4 digits between 0 and 9 are randomly selected with replacement for a lottery ticket, what is probability that at least one of the digits is 7? So we're gonna let A at least one of the digits is 7. So think about it. What is the complement of A? If we want to get at least one of the digits is 7, the complement will be none of the digits is 7. And then we're gonna apply the complement formula. So none of the digit is a 7. We do have a 4 digit. So for the first digit, we want to find the probability that the first digit is not a 7. So think about it. For the first digit, we do have the choice from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We do have a 10 numbers in here. And then we don't want any 7 here. So we cross it out. So what is a probability that the first digit is not a 7? That will be 9 over 10, right? I can pick whatever I want, just I don't want to be a 7. So we do have a 9 option out of 10. Second digit is not a 7 also. Same idea. We don't want a 7. We do have a 10 choice. So that will be 9 over 10. Same idea with the third one and also the fourth one. So we will have 1 minus 9 over 10 to the power of 4. Use your calculator. You're gonna get 0.3439. Okay, example 3. The company that manufactures M&M, 12% of peanut M&Ms are brown, 15% are yellow, 12% are red, 23% are blue, 23% are orange, and 50% are green. If you randomly select 3 peanut M&Ms, compute the probability that at least one of them is green. Okay, at least one of them is green. 1, 2, 3 decimal space. So first, we're gonna let A be at least one of them are green. And then let's write the complement. At least one of them are green. Complement will be none of them is green. So complement formula. And we want to pick 3 peanut butter M&Ms, right? So 3 of them. So each of the probability that's not green. Since green are 15%. So I can get whatever I want, just not the green one. So that will be 100% minus 15%. Okay, I can get yellow, I can get red, blue, or orange, just not the green one. So 100% minus 15%, which is going to be 85%. Okay, and then we're going to pick 3 M&Ms in here. So use your calculator. You're going to get 0.386. And this is going to be at least one's probability. Okay, general multiplication rule. We talk about it on the session 4.2 when we talk about the dependent and independent event. Okay, remember that when we have the dependence event, we're gonna apply the general multiplication rule. You could think about the example like drawing the marble. When I pick one marble, I fold it away, and then I'm gonna pick the second one. So that's a dependent event. We need to apply the conditional probability. Okay, right? So now, I have the general multiplication rule. I try to divide it by probability of A for both sides. So these two I could cancel out. And this guy, we call, this is the conditional probability. Probability of B under the situation of A, that would be equal to probability A and B over probability of A. And this is called conditional probability. So suppose 2 events occur, event A and B. Conditional probability of B given A. Tell us the probability that event B happens after we already know the event A has happened. Example 4. We toast one fair 6-sided die, and we're gonna let A be the even number. And then B will be the number 1, 2, 3, 4. Find the conditional probability, finding probability of A given B. So since we know this is a conditional probability, let's write down the formula. And then we try to write it out in a sentence. So this is mean I want to find probability A and B. I want to find the probability of A, which is going to be even number, and also the B, 1, 2, 3, 4, over the number of outcomes of probability of B, which is going to be 1, 2, 3, 4 here. So think about it. Even number, we do have 2, 4, and 6. Right? In a 6-side die, we have a 2, 4, and 6. So 2 and 4 will be matched with the B here. So that will be two numbers on the top, on the numerator. And then the number of the outcomes, I need to be 1, 2, 3, 4. So we do have 4 outcomes of it. So final answer will be 2 over 4, which is going to be 0.5. Okay, example 5. In 2005, 19.1% of all murder victims were between the age of 20 and 24 years old. Also, in 2005, 86.9% of murder victims were male, given that the victim was 20 to 24 years old. So the second probability here, this is talking about the conditional probability, because this is a given that. Okay, the probability that the murder victims are male under the situation that the victim was 20 to 24 years old. What is probability that a randomly select murder victim in the 2005 was a 20 to 24 years old male? Okay, I highlight this one. This is talking about we are looking for the probability. 20 to 24 years old and male. So this is going to be the multiplication rule. So we are looking for probability age of 20 to 24 and male. That will be equal to A, which is going to be probability of 20 to 24. Okay, the age of 20 and 24. We do have the information here already. And then second one will be the conditional probability. Probability that the murder victims were male, given that the victims was 20 to 24 years old. Okay, given that, that's a conditional probability. So plug it in. We're gonna convert the percentage to the decimal. Okay, you could move the decimal space, 2 space to the left. Okay, 2 space to the left. And then multiply it. So you should get 0.166. Okay, example 6. The number of United States men and women in millions 25 years old and older who have attained various levels of education as of March 2007. 1 to 4 significant digits. Number of men and women with various levels of education. So we do have a number of men, number of the woman, and the man who is not a high school graduate, or the man who is advanced degree here. So first, what is probability that the person is a man? Okay, we do have a 94 men here. Out of the total numbers, the man plus the woman. So you should get 94 over 195. 4 significant digits. So talking about not counting the 0 here. So 1, 2, 3, 4. B. What is probability that the person is a man with the bachelor degree? So bachelor degree will be here with a man. So that will be man and bachelor degree. That will be 17.5. Out of the total, 195. Which is going to be 0.08974. One more time. 4 significant digits. We don't count for the 0 here. Okay, so 8974. C. What is probability that the person has a bachelor degree given that the person is a man? Okay, again, highlight the given that. This is gonna be the conditional probability. So we're gonna write it out. Probability of the person is a bachelor degree under the situation that he's a man. Okay, we're gonna plug into the formula. So on the top, that will be bachelor's degree and man over probability of man. So bachelor degrees and the man, which is going to be 17.5, over the man. How many men are there? 94. So you should get 0.186. Example 7. The table below displays results from experiment with polygraph instrument. Find the positive predictive value for the test. That is, find the probability that the subject lie given that the test uses a positive result. So we are looking for the conditional probability again because I see like given that, right? So first, write it out. We want to find the probability that the subject lie. So probability of lie given that the result is going to be positive. So write down the formula. So numerator, there will be probability that lie and positive over probability of positive. Okay, how many of them are lie and positive? Lie and positive, which is going to be 44. Out of positive, so that will be 14 plus 44, which is going to be 58. So you should get 0.759. That's it.